I was going to exactly say that. Like, I'm the only guy between your lunch and me. Sorry. Anyway, I tend to speak fast, so I gave this talk last time at a conference and everybody complained that I spoke really fast. So if you feel that I'm speaking fast, you should wave your hand. If you don't wave your hand, you get an early lunch. So, which is the talk on lunch. Okay, we'll get started. So, there were a lot of fabulous talks. Most of them were very holistic and they were all about really big stuff. But I'm going to talk about just attacking stuff. And it's going to be a very narrow, it's a very niche thing. I'm going to talk about doing reconnaissance like it's 2017. So I'm going to talk about a bunch of reconnaissance techniques that people don't know a lot about or they're very recent. So let's get started. I am Bharath Kumar. I work with a startup called AppSecco. It's in Bangalore. When I was coming to BSides, I thought I'll see all the old faces from Null, but there are a lot of new faces. I have an OSCP and all the other stuff. So I am going to talk about a bunch of DNSSEC attacks. If after the talk, if you want to run, you can run it against that name server and that domain. That is owned by me, so you have the permission to do that. You'll get the slides after the talk as well. So let's get started with this idea. What is reconnaissance? Reconnaissance is about gathering intelligence or information about a target. So when you start attacking, if you're a pen tester or if you're a bug bouncer or even if you're a bad guy, when you want to attack someone, the first thing that you do is you gather information. And why do you gather information? Because you want to plan your attack. Or sometimes even in gathering information, you get complete access. There are people who don't exploit at all. They just get access using information gathering. And it can be done actively or passively, but for this talk, we don't care about it. It's active or passive, it doesn't matter. So what do we look for when we do reconnaissance? When we do reconnaissance, we look for increasing attack surface. We try to find more domains. Usually I think there are a lot of bug bounty hunters in the crowd, so if you start a bug bounty or if you start a pen test, you start with a single domain. But after that, you find more domains and then you try to find more bugs. That's how you do it. You try to increase the attack surface. And also you try to find credentials. It could be emails, could be passwords, could be API keys. And you try to find sensitive information. Could be documents, anything like that. And infrastructure details, like what technology they are using, what servers they are using, things like that. So this is exactly what we look for when we do information gathering or reconnaissance. So what am I going to cover today? I'm going to cover about a new standard called as certificate transparency and how we are going to use it for reconnaissance. I'm going to talk about DNS zone working, DNSSEC zone working, and I'll talk about how to hunt for publicly accessible cloud storage. So how do you get sensitive information that is hosted out there and it's publicly available? And the next thing is code repos for reconnaissance. Like a lot of people put open source code out there, a lot of people put their code online, and you could find a lot of interesting information or sensitive information in the code. That's something we look at. And also we look at using public data sets to do passive reconnaissance. You find a lot of internet scanning data out there, you could take it and you could do a lot of reconnaissance and you find a lot of interesting stuff. So on a very high level, this is what we are going to cover. So the first thing we are going to start with is certificate transparency. Have anyone of you guys heard of what it is? Okay, you are in the right room. So certificate transparency is a Google standard. It came up a few years ago. The idea is that Google came up with this idea where you are going to put all the SSL TLS certificates that has ever been issued. It's not this year or it's not ever. It's by all the certificate authorities ever. Every SSL TLS certificate is going to be in a single log file or multiple log files, but you know where the log files are going to be. Okay, that is the link for the known logs. So you have these log files, and in that you have all the SSL TLS certificates ever issued. What is the idea behind certificate transparency? So you have all the SSL TLS certificates in one place. Now you look for all the certificates. For example, you want example.com. You are an administrator. You go there, you have 10 SSL TLS certificates. But when you look into this log file, you have 15. Then you know that the other 5 are rogue certificates. Rogue certificates are a massive problem in SSL TLS world. Like you have a fabulous technology, you have HTTPS, but just single rogue certificate can break the whole thing. For example, Symantec gave a rogue certificate for Google. Like a few years ago, it was a massive issue. Like just one certificate would break the whole HTTPS ecosystem. So rogue certificates are a problem. This is how Google started fighting it. Put all the certificates in a log file, look into it. If you find more, that's going to be rogue certificate and contact your certificate authority. So that's a fabulous idea.
So how does it make it helpful for others?
Excuse me, and use your mind.
You can ask the question. If it's a longer question, I'll take it in the end. So yeah, go.
So just a small question. So I just want to understand how does this benefit someone?
So public, I'm going to talk about it. You have search engines where you can search these certificates. So you are a domain owner, you go to this certificate, you go to this search engine, you put, for example, you own example.com. You just put example.com, you get 15 certificates. But in reality, you have only 10. So you know that 5 certificates are not owned by you, somebody else got it in your name.
So basically the Google owns the responsibility of making the...
not really, certificate authorities. I'm going to get that question later because I have a lot of content. It's by certificate authorities. Like if you are a certificate authority, you can have your own log file, but the idea is that you should put your link over there, certificatetransparency.org, no log files. So bottom, I blogged extensively about this technology, so in the bottom you'll see the references. If you want to read more about it, you could go read there. So side effect, you are going to get all the SSL/TLS certificates in a log file, but the problem is that SSL/TLS certificates will contain domain names, subdomain names, email addresses, and everything. So for a domain, anybody can look through the log file. So if you are attacking, for example, Tesla.com, Tesla has an open bug bounty with background, so there's nothing wrong with talking about that. So for example, if you want to attack or if you want going for a bug bounty program for Tesla.com, you go there, you search all the certificates for Tesla, you find out all the subdomains in the certificate, so you find all the email addresses, and then you start your attack, you increase your scope. So that's how you do it. The side effect is all the SSL certificates will have sensitive information and you could actually get it. There's no one who can stop it. And the better yet, it's going to be completely passive. Nobody will know that you actually accessed it. So how do you do this? That question. So you have a bunch of search engines. The first one is crt.sh. It's by Komodo, Certificate Authority. You can go, you can put a domain there, and you can just get all the certificates. As simple as that. It's like Google. And census.io is by Michigan University. They do almost the same thing. They collect all the SSL/TLS certificates and you can search for it. Facebook actually endorses certificate transparency, and they actually came up with a tool where you can actually search that. It's that way. Facebook actually found a bunch of certificates issued for them which were rogue. And then Google itself, because it's their project, they have their own HTTPS certificate transparency report project where you can find it. Any of them are authoritative, like all the results are consistent. You can use any of the search engine. I prefer crt.sh, just a personal choice. So for example, this is crt.sh. If you look at it, I just went there and I put some domain name. I'm not going to tell which company that is. It's probably you all took that company's thing to come to this venue. I'm not going to talk about it. It's a 4-letter company. So anyway, so you could find a bunch of domains, and if you see, there is the interesting part. I can't point it there, but you can see the red arrows which says Git and Jenkins. So there's no way of you knowing there was Git and Jenkins for them, but when you go there, you could actually find it. So I'm going to do a simple demo for that. So for example, if my internet works, I'm going to do this. I want to attack Tesla.com. So Tesla Motors is their domain. I go to crt.sh, I just put it here. So now you can see that. Can you guys see this? Yeah, you can see a bunch of subdomains. Shop.eu, shop.uk, streaming, Tesla Motors, VPN, bunch of things. You could find some subdomain where there's an application that might have vulnerability. There are tons of them. But if you notice, there is a problem with this. There is a lot of repetition. Bunch of results are repeating. So for that, I just wrote a simple script. This is going to be available in repo. This is called as crt.sh. And just say something like Tesla Motors.com. Okay, I wrote it in Python 3. If it's slow, it's the internet, because this script is supposed to be super fast. So yeah, you got a bunch of domains, and these are all unique, and these all belong to Tesla Motors. So this is how you do it. If you're a bug bounty hunter, this is a brilliant technique. Even if you're a system admin, if you're a system admin of a company, this is a brilliant technique. You should keep checking your log files so that you understand it. And the next thing, so this is my script, and I ran it against Tesla Motors. That's the result. The script is available over there. You can see the link. The next thing, this is another script I wrote from census.io. This is just another script that's going to census.io and getting all the subdomains. You have that script as well. And this is the interesting part. So Facebook not only lets you search, they also have this idea where you can actually put a subdomain and you can subscribe. So whenever a new subdomain comes up for a company, you can actually get an email alert. So if you're a bug bounty guy, for example, if you're targeting Tesla or something, you could just subscribe to it. So whenever a new domain comes up, you get an email alert. You could go test it before anyone else. This is a very interesting technique. So downsides of CT for recon. The problem is that CT logs are up and only. You can put entries in that, but you can't delete it. It's going to be there forever. It's something like blockchain. So that's a problem. If it's going to stay forever, you're going to have a lot of domains that don't exist anymore. For example, I do this. Now I gave it up. So Uber.com, you could see something here. I think probably some bug bounty guy added a domain over there. So you could see someone had brought2.uber.com. So that domain actually doesn't exist, but you could see that. There's no way of Uber removing it. It's going to stay there forever for everybody to see. Does it make sense? Okay. Or am I going too fast? Too fast. Okay, good. Oh yeah, perfect. So this is the idea. What I talked about is unresolvable domains. So you have a bunch of entries. For example, for Tesla, there were like 200 or 300, but there were only 10 or 15 that are valid. How do you handle this? There is a tool called as Mass DNS. It's written by someone from Technical University of Munich. It's written in C and it's a super fast DNS resolver. So it's going to resolve like millions of domain names in few minutes. So what you could do is, what I'm doing over there is, I'm running cd.py, which is going to get all the certificates for example.com, and you can see the command here. So I'm giving it to mass DNS, and these are a bunch of command line options. You could read about it. So what it does is, it takes each of the domain and it checks if it has a valid IP address and valid IP address. Only if there is a valid IP address, it's going to print. So right now, you started with certificate transparency, you got a bunch of domains, and there were a bunch of repetitions. You used that script to make unique domains. Now you use mass DNS to get unique resolvable domains. So that's a really good technique if you're a bug bounty hunter, or even if a security professional, it doesn't matter. So what is one of the use cases? So this is a fabulous technology, we talk about attacking stuff, but is there any use case? So for example, when you are setting up something like WordPress, Joomla, Drupal or something like that, few of the content management systems, when you set it up, I'm pretty sure a lot of people in this room set some content management system at some point. So when you set it up, at first there is no authentication for some period of time. And a lot of WordPress, they support HTTPS when you begin with it. So at some points, so when you start a WordPress, it's going to be there on the CT logs. You get a HTTPS certificate, so the domain is going to end up in the CT logs. So if the attacker can find your domain on that before you can install the WordPress, or if you leave the WordPress for a day or two, if you can get it, he can actually take over your domain itself. Take over your application itself. And the interesting part is that CD is really well implemented that it happens in near real time. You get a SSL certificate, you can just look it up on CT logs and it will be there in real time. So that's a scary thing. A lot of these content management systems actually fixed it after reporting. I did not report it, but this guy reported it. So this technique has been presented by Hannenberg at DEFCON 25. He claimed to have found 5,000 WordPress installations like this. And also H.D. Moore, the guy who wrote Metasploit, he talked about this technique at BSides Delhi 2017, a few months ago. So CT log mitigation. How do you mitigate it? So now you're a system admin, you don't want your logs, you don't want your domains to end up on the log. The easiest way is don't have SSL or TLS. Just don't do that. This is a fabulous thing. This is the easiest technique, but don't do that. You have a domain, you should have SSL TLS. That's it. Oh, I forgot to put a website there. Do I need HTTPS.com? That will explain why you need HTTPS. So, not having SSL TLS is not an option. Have SSL TLS. Other thing you could do is, you could use wildcard certificates where you say star.domain.com. So you're not going to give the details of the domains, subdomains itself. But the problem is subdomains are a single point of failure and you should not use it. The RFC that talks about subdomain, RFC that talks about wildcard certificate itself says not to use wildcard certificates. And the other mitigations, right now the problem is that you are using a public CA and this guy is going to put all the things in the log. So you could, if you are a large enough company, you could actually have your own public key infrastructure, PKI, you can have your own internal certificate authority for your internal domains. For external domains, there is no way to do it. For that, you have projects like CFSSL, Search Manager, where you can build your own private public key infrastructure. Opt out of city logs, that's straightforward, but you're going to miss out all the security benefits that you get out of it. And there's also this interesting discussion going on where they want to redact the subdomain part in the city logs, but that's not going to help because if you are going to remove the subdomain part, there's no way that you would know that what the certificate is issued for. It's pointless. So these are the ideas if you want to look back at it. I'm going to skim through DNSSEC because it's not really, the details of DNSSEC itself are not important. We go to the second topic. So DNSSEC, in normal, DNSSEC is adding a layer of security in normal DNS by adding cryptographic signatures. So usually when you do DNS, when you go for example.com, you just get A records. In DNSSEC, you get security because you also get a cryptographic signature where the server signs it with its private key and it also gives you the public key. So you can actually verify that you got an authentic answer. That is the idea. So DNSSEC adds, it's okay if you don't understand this. So DNSSEC adds a bunch of new records to the DNS. First one is cryptographic signature. So if you have a records, it's going to sign and it's going to put a cryptographic signature there. But just putting a cryptographic signature doesn't help. It's going to put a public signing key by which you can verify that authenticity of the crypto key itself. So there is a problem here. The problem is that denial of existence. So let's say you ask for a subdomain or domain that doesn't exist. In DNS, in normal DNS, when there is no DNS set, the way it works is you get an answer called as NX domain. It's a very generic answer. For any non-existing domain, you're going to get the same kind of answer. It's called as NX domain and it's very simple. But the problem is in DNSSEC, it's a little harder to do. That's because if you're going to do generic NX domain message and if you're going to authenticate, attacker can just spoof it because he knows the message, he can just generate it. And signing responses on the fly doesn't happen. So in DNS, when you are signing the records with private key, it happens offline. Because DNS is a distributed system, you can't give your private key to every server. You actually sign it in one server, and then you give the signed records to all the other people. You don't actually sign it in all the servers. The more distributed private key is, the weaker it is. Pre-signing all the NX domains is not possible because there are millions of, the number of possibilities is the number of possibilities in English itself. So the problem is, so how does DNSSEC handle it? There is something called as NSEC. So NSEC is a record where, for example, if you ask for a non-existent domain, like example.com, what it does is, it says that, so let's say abc dot, not like abc, let's say xyz.example.com, you ask for it and it doesn't exist. The way it says is, it puts all the records in alphabetical order, all the domains in alphabetical order, and then it goes to the previous domain and gets you the NSEC record. It actually did not make sense. So anyway, let's put it this way. In DNSSEC, you could use there are two records that you can use to deny the existence of a domain. Can you guys see this? Can you guys see the screen? Okay. So in DNSSEC, there are two things that you should know about this. There is NSEC record and there is NSEC 3 record. So if someone is using NSEC record, the way you get their subdomains is LDNS. LDNS is a utility, it's a Linux utility, LDNS over. For example, let's just say these guys use NSEC. You get all the subdomains. I'm going to stop this. This is a very interesting technique. So you could also do for something like NIC.in, it's National Informatics Center of India. If you do it against this domain, you get all the domains that they own. It's around 6,000 or something like that. So that's actually interesting. It's a very fabulous technique. Not a lot of it's been there for a long time, but not a lot of people actually know about it. It's a very fabulous technique. So this is how you do it. That's iano.org. I ran it against it. This is how you install it if you want reference later. Skip this one. NSEC 3. So NSEC is clearly vulnerable, or some people agree that it's vulnerable. So people who come up with DNS protocols, they came up with something called as NSEC 3. So in NSEC 3, if you see, the interesting part is that there is no domain name over there. There is a hash over there. So right now, even if you want to walk the domains, so last time I said it's called NSEC 3 walking because it's a linked list. You ask for non-existent domains and you get all the domains. That's NSEC. So in this, if you're going to walk, what you get is you're only going to get the hashes. This was supposed to stop zone walking, but it did not stop. It just made it a little expensive. So the idea is that I'm just showing an example for example.com. So if you ask anything between example, www.example.com, example.com is going to tell from example.com to www.example.com, nothing exists. Something like that. So this is NSEC 3. So there are tools like NSEC 3 walk or NSEC 3 map by which you can actually walk this zone as well. NSEC 3 is not, it's a fairly reasonable protection, but if somebody wants to get your domain, they will get your domains. It's only a matter of how much computation power they have. So if you install NSEC 3 walker, you get two scripts. One is collect. You just run collect against the domain name and it collects all the hashes. And you have another script called unhash. When you run this, it's going to unhash all the hashes and it's going to give you a domain. What happened when I ran it against ican.org? So I ran it against ican.org. I grabbed only ICANN and then I did a word count. I got 182 domains. Sorry, shouldn't have done that. Yep. So I got 182 domains of ican.org. There was no other way of getting it. They were trying to protect it, but we could get it. This is interesting. So if you are using DNSSEC, NSEC and NSEC 3, you could still walk it. So there's also another interesting thing that HTTPS and DNSSEC are supposed to be protocols that protect you. But now if you use HTTPS, you are going to end up in CP logs. But you use DNSSEC, you are going to end up with zone walking. So this is a very interesting thing from a threat model perspective. Like you try to make something secure, but you are introducing some security there. Just an idea to think about. Installing NSEC 3 walker, that's for reference. So I'm going to talk about APIs and DevOps because my talk is so. So few things, I'm going to talk about how reconnaissance changed with APIs and DevOps. Not reconnaissance as such, what changed with APIs and DevOps. There are a lot of things that changed, but for the scope of this talk, things that changed are the way we do storage changed, the way we do authentication changed, and there's a lot more code now. You talk about DevOps, you talk about SecDevOps, you write a lot of code, and there's a lot of CI/CD pipelines. So how does this affect us? Let's see storage first. cloud storage has become really inexpensive. Right now, everybody is putting their data on cloud storage. It seems that it has gained popularity. How many of you guys use S3 buckets here? Sorry. Okay. So, cloud storage has become very easy and very easy to set up. So, it has gained a lot of popularity. And you could put anything on there. For example, if you talk about object storage, like S3 is an object storage, or DigitalOcean Spaces is an object storage, you can put anything, audio, video, documents, anything like that. The problem is, when you give people a chance to put anything, they will put anything. That is the problem. So they're going to put their plain text passwords, they're going to put pictures of their pets, anything on there. And putting anything on cloud service is okay, but don't put it publicly. That is the problem. So let's talk about Amazon S3 buckets. Amazon is AWS S3 bucket. It's a service by Amazon. It's a storage service. It's object storage. You can put anything over there. So the idea is you can store large amount of data. It's fairly inexpensive. The problem, Amazon S3 buckets is used by literally everyone, from web developers to massive companies. They use it. But the problem is this: September 2017, there was this attack on Accenture. It was a major attack, and it happened because of misconfigured AWS buckets. That's one attack. It's by Akbar. Taking a look at it again, Javed Malik is from Alien World. He says that massive breaches to unsecured AWS are a trend now. So people put it there and they just put it as public for everybody to see, and they will just download it. And also, this is just another news article where they talk about AWS attacks being the flavor of 2017. So, but the irony of it is, when you start AWS S3 buckets, Amazon understood that people are going to put it public and it's going to be insecure. So Amazon made it by default, AWS S3 buckets are going to be private. But the irony is that there is someone who actually put their sensitive data over there. They went there and they clicked the public button. Like, I put my public data there and I'm going to put my sensitive data there, I'm going to make it public. It's a conscious decision that someone took, especially over here at Accenture. I have nothing against them, but it's interesting because they're a large service-oriented company. If they can get hacked, probably anybody can, but yeah. So how do you hunt for S3 buckets? So there are S3 buckets, you know that there is data, but you want to hunt for S3 buckets. The idea is that every S3 bucket has a predictable URL. The only thing in the URL that changes is the bucket name. All the other URL is going to be the same. So now you can think about an attack against this, dictionary attack. You can just take a dictionary, you can run all through it. It's like brute force, it's a little smarter way of doing it. I'm going to talk about it in a while. So that's the idea. Also, you could do something like Google Docs. Google Docs is basically advanced Google searches, where you say, I want to check S3 Amazon AWS.com. This is the base URL for Amazon, and then you say, I want file PDF. You could get PDFs that are publicly available. Or you just say password, and you get all the S3 buckets that says password. This used to work brilliantly a few years ago, but now it doesn't work because everybody searched through all over Google and they got the data. But the other interesting part, what I was talking about, dictionary-based attacks. So this is how AWS works. You can't just change it because the bucket name is unique, so you can actually run a dictionary attack. And there are tools to do that, AWS Bucket Dump and Bucket Finder. This is a fabulous tool. I like the first one. A lot of people like the second one. The second one is written in Ruby. But yeah. So that is the idea. You can actually find those. But again, to reiterate it, putting sensitive data on S3 buckets is still okay, but don't make it public. That's the insecurity, not putting it on S3 itself. But ideally, you shouldn't be putting any sensitive data on third parties. So DigitalOcean Spaces. Spaces is, again, it's an object oriented. It's exactly like AWS S3 buckets. It's by DigitalOcean. They released it, I think, 4 weeks ago. They just wanted to, and from a business perspective, they just wanted to compete with S3. And they just released this service called as Spaces. So Spaces API aims to be compatible with AWS S3 API. That's the idea. If you look at it, there is a URL pattern to this. You have a space name, and it's going to be in some region at the bottom of it. And on the black part is consistent, DigitalOcean Spaces.com. So again, you could brute force it. You could find all the regions, you could put it in a file. You could find all the bucket names, and you could brute force it. So just to talk about it, a publicly accessible S3 bucket or a publicly accessible space will look like this. When you go to that URL, it actually shows you what file is there and the bucket name. But if you put it private, it should do something like this. It should say access denied. So public versus private. This is public, this is private. If you have it public and if you have some sensitive data on there, that's a problem. So when Spaces got released, I had an interesting idea where I wanted to walk through Spaces itself, but there was no tool to do that. But the But what I was talking about, it's API compatible with AWS. So I took this tool called an AWS Bucket Hub, and I just modified it to work with spaces. Let me just give you an example. So, so it's just, I'm just going to give you a bunch of space names that I think that the company owns, and I'm going to say interesting keywords. Interesting keywords is going to be .txt, .pdf, .bak, what files I want to see. This is the spaces of bucket guess name. This is just a file. And if there is anything public I want to download, maximum file download should be 50,000 bytes or something like that. I run this. So it's going to look at a bunch of things. The internet is good. So bunch of them are not accessible. If you look at it, it's looking at it and it says not accessible. So those are private. Let's take a look. You see a red mark over there. So that's actually publicly accessible. Now it's going ahead and downloading all the files over there. It's available on my GitHub if you want. Right now, not a lot of people are using DigitalOcean spaces, but for sure in a year or two, people are going to use it. If you can use a tool like this, or if you can use if you can do it on a scale, this will be an interesting research idea. So that's where you would find the tool. It's go space -finder. You get the tool. I'm going to give the slides anyway.
Can you able to find water buckets also?
Sorry?
Water buckets, AWS buckets, water DigitalOcean and water bucket.
Oh,
Jokes apart.
Probably if you know the API, you could just write a simple tool. It's just a couple of hours of it. I found DigitalOcean spaces interesting because DigitalOcean has a lot of backup, so they would probably get popular. And they're super cheap. That's important because I'm going to tie it up with another function. So this is the tool that's running. It just downloads, it finds all the public things, it lists all the files and it downloads the files. And the other thing that changed with APIs is authentication. Previously we used to do emails and passwords. Now we do API keys everywhere. Like you have a service, you just put API key. What does your API key give access to? Everything in the service. That's a really big problem. Like if people don't consider API keys, if you don't tell people something is a secret, they don't consider it like a secret. They just see API keys as a string that just gives you access. But it's way worse than passwords. You could find it everywhere. Daniel Islam has a great blog on that. You could read about it. Why did I talk about that? Because of this. So if you are a bug hunter or if you are a penetration tester, this is something interesting. You can look at code repositories for reconnaissance. The idea is that the code, you can find all, for an organization, you can find all the code online, and there's going to be a treasure trove of information. You can find credentials, you can find vulnerabilities, infrastructure details, everything in code. So for example, can you guys see that? It's, okay, I'm going to say this is Deloitte.com plus password, and it gives you results, 640 results, and it's code. So if you guys did not know that company got hacked a month ago, it was a major breach. And they are a cybersecurity consultancy. Just to, I think they are part of Big Four. I don't know. Yeah, they are part of Big Four. Cybersecurity consultancy, and you just go to their GitHub, put it, and few of those parts, I did not try those. So GitHub, I talked about code for reconnaissance. So let's talk about GitHub for reconnaissance. GitHub is again a version control system. Probably, I'm pretty sure a lot of people use GitHub. If you did not, I think probably on the wrong code. So code repos on GitHub then they have all the sensitive information. It's like code again. It's just a version controlling platform. But the interesting point is GitHub has a really powerful search feature, and also it has a really well-designed REST API. So Ed Overflow is a bug bounty hunter. He's a fairly popular bug bounty hunter. He wrote an article called as GitHub for bug bounty hunters. Few of my next slides are going to be his work. I'm just giving you the credit. So things to focus on. If you have ever used GitHub, there are 4 things. One is repositories, which is the project itself. The other one is code, the code files. The other one is commits, and there is something called as issues. The idea is that if you look at a repository, you can see what it does. For example, if it says the repository says something like passport manager, then that's a critical software. Maybe you should go find bugs there. At the code level, maybe you can find API keys in there, maybe you can find password subdomains in there. At a commit level, that's my favorite because when you talk about GitHub, for example, someone puts a sensitive data over there, and then suddenly they go there and they delete it. But the problem is that it's going to be there in the commits. That's something a lot of people don't recognize. And issues is another interesting thing because people are going to raise issues. Few people raise issues like there is SQL injection in your code. And if the developer is somewhere on a holiday, you're going to take over the application. Just for an example, is there something wrong with this image? I already pointed it. What seems to be the problem? So basically this guy wanted to delete his private SSH key that he put in the code. He deleted it, but his commit still shows it. That's the problem. That's how people don't understand how version control works. So if you run into this problem, what you should be using is git rebase, or if it's your last commit, it's very easy. I think you do something like git head, something like that. It's a very simple command. But it's your older commit, then you do something called git rebase, or there is something called cherry pick. That's how you remove your previous commits. If you have any, go back and look at your commits. If you have any sensitive data, please remove it. I learned it that way. I learned git rebase because I put my SSH, not SSH, I put my password in GitHub by mistake. And then I learned git rebase, I removed it. You can find it now. And the other interesting thing, this is about issues. When you go to GitHub issues and you type just vulnerabilities, few people complain about SQL injection in data. We use multiple XSS vulnerabilities in the code and they are not fixed when I took the screenshot. So somebody, if this application is popular and if it's outside, somebody can actually take over it. Take it over. So how else do you do this? Mass cloning in GitHub. So if you're targeting an organization, you could go to the GitHub account and use tools like GitHub cloner.py. You could get all the code and you can have a local copy and then you can analyze it. That's a very good way of doing it. This is a very handy tool. And static code analysis. Once you get this code, what you could do is, rather than going through all the code, first you could send it through some automated static code analysis tools, something like Brakeman for Ruby or Bandit for Python. These are the tools those are security linkers where they look code and they warn you about basic security problems. So this is a very low hanging fruit for bug bounty hunters. Manual search. You take the code and you just do Control F and then you look for API, password, keys, tokens, HTTP, things like that. What else do you do? GitHub Docs. So Google Docs are like, if you are to security scene for a while, you would understand what Google Docs are. So Google Docs are advanced Google operators where you can search things like specific file name from a specific domain, things like that. GitHub also has a really powerful search. So you have something called as GitHub Docs. There's a collection of it, some guys wrote over there. But if you're going to attack some organization, you should have your own customized Google Docs. But you have a list over there. And then there's a tool which has bunch of GitHub Docs, and this runs the GitHub Docs against your repository itself. These are very interesting to look at. So my last topic is passive reconnaissance using public data sets. So there are various projects out there where they do internet-wide scanning. Like these guys have massive amount of funding, like these are universities and people with massive funding. They do scanning over the internet and they collect a lot of data and they put it online. It's terabytes of data. And researchers and security community could use it. It could be DNS data, SSL, DLS data, everything. You could find a lot of interesting information, but the problem is it's going to be like finding needle in a haystack. It's going to be a terabyte of data, but you're going to find like 10 or 15 domains. So why use public data? If you have a local copy of a data set, you don't need to rely on third-party APIs. So for example, if you're doing a pen test, you don't want to put your client data on a third-party service. There are a lot of people like SSL, Val's SSL lab. If you are doing a pen test, you're going to put your domain there. But do you trust Val's? That's a question. So you want to reduce your third-party API dependency, and you want to reduce the active probing of target infrastructure. If you have a local massive data set, you could look at it, you could look into it, and you find interesting information without probing the target itself. And you can build your own recon platforms with the data. So these are a bunch of data that's available out there. I just put it because you can refer to it. These are all, few of them are paid, few of them are free. These are massive data sets. If you look a little backwards, the third one is CT, which is certificate transparency. So that's where you can get all the certificate transparency logs. You can download it. I think with a decent internet connection, it will take you like 10 or 15 days. It's that massive. So these are the data. I want to talk about the last thing. There is some data set called as Rapid7 forward DNS data set. This is by Rapid7 company. They scan all the internet for a DNS any query or something, and they put this data set online. The idea is that in this data set you can find most of the domains on the internet. I'm not going to say all the domains, but they try to find almost all the domains on the internet and they put it there. It's a massive data set. It's 20 GB compressed and 300 plus GB uncompressed. So what is the problem? So you get this 20 GB file. What you could do is you could run this bunch of commands. So I'm just chatting the output of the CZ file. I'm going to giving it to pigs, which is a multi-core decompressor, and I'm looking for example.com. So I can find all the domains in this data set. So this is again completely passive. I have a data set. I'm looking for domains, and there is no way for the organization to know that I'm looking at it. This is a very fabulous thing. And also this is JSON format. You can actually load this data into your Elasticsearch and things, and you can actually get visualizations. That's how you scale reconnaissance. So for example, this is a little hard, it's hardly visible. So in the first command, what I'm doing is I'm catching the whole 20 GB. I'm not uncompressing it, I'm using a tool called as pigs, which uncompresses on the fly. and I'm trying to get all the domains for, well, that's uber.com anyway. And then I'm trying to print all the domains. That's it. It's a very fabulous technique. I use it at work fairly often. So that's about it. And then I gave the same kind of talk previously at Bharath Level Up conference, and I made a simple cheat sheet for subdomain enumeration, which you can download. You can look up what techniques work for you. So you can get this cheat sheet at that link. And this is interesting. So after speaking about it, I want to show you this visualization where I ran these techniques against ICANN.org. So the first technique is sublister. If you are in security, you might have heard of sublister, which is it's a simple Python script which searches all the search engines for subdomains. So I found 278 subdomains for ICANN.org. These are unique resolvable subdomains, no repetitions, no invalid domain names. And using certificate transparency logs, I found around 46 or something. Using forward DNS dataset, I found 3,681 domains that belong to ICANN.org. Why did not those show up in the other is because most of those domains are SMTP and mail servers. So there's no way that they would show up in other ones. And the last one is zone walking using NSEC. I found 182 domains. So this is how efficient they are. You can just think about it. Not the same technique works against all the domains. You should think about how your domain is. Like if you have NSEC 3, there's no point in running NSEC scanning. Or if your domain doesn't have HTTPS, there's no point in looking at certificate transparency logs itself. So you should know what you're doing. Just look at it. You can find a lot of information. The talk material, the scripts that I talked about are available here. The slides are there. If you want to take a picture, you can take a picture. There are a few scripts that are not there yet. I'll push it today. I'll put the slides as well. These are the references that I did not put in the slides. I work with this company called as AppSeco, where we do pragmatic security. I did a lot of research in the office time, so it's fair to put their slide. So that's my Twitter. If you want to follow, you can follow. If you have any questions, you can ask me. I think we already ran out of time.
And you have another 5 more minutes. We can ask audience to ask questions for you.
Oh, nice.
I think. Can you use mic so that other one can also use?
What just happened? Yeah. Which technical? Which slide are you talking about? Oh, you want this one? The better one would be the one on the bottom, because I have all the scripts over there. This is from another conference. This repository has all the scripts. And it has a bunch of cheat sheets as well. I did not want to repeat it in this conference, so I did not put those. And probably besides Twitter account, we'll read the slides as well. If you have any questions, you can ask. I'll be available offline.